Yes.
If there's like a minus sign or something, like the negative symbol in front of like the two lines, that makes the reflection.
Yes. Okay, I'm zooming in here. I'm going to start going over 16, 17, 18, 19. Those are pretty simple questions. That's why I assigned them for bell work. It says state the type of function and then describe the transformation for the following functions. So here, because of that square right there, we have a quadratic. So that means the graph is going to look like this. And then minus 7 would mean to the right 7. And then plus 9 would be up 9. Did y'all get that?
I didn't read the instructions all the way through, and I just wrote quadratic and absolute value. Whoops.
17 would be absolute value. So our graph will look like this. And then plus 6 would mean left 6. And then minus 10 would be down 10. And then for 18, we have another absolute value, but it does have that negative symbol in front, so it is going to be a reflection, so it'll actually be pointed downwards. So reflection. And then plus 12 would be up 12 for the original point. And then for 19, we have a quadratic, so that's square there, quadratic. So our graph is going to look like this, but it's going to be rather steep because of this stretch of 5. So it has a stretch of 5. Plus 10 would be left 10. And then minus 3 would be down 3. Okay, and then for 20 and 21, you probably have been practicing this on Khan Academy as well with the x and y intercepts. I'm going to start with number 20. I'm going to set up a table, x-intercept and y-intercept. And on one side of the table, I'm going to solve for the x-intercept, and for the x-intercept, y equals 0, and then for y-intercept, x equals 0, so it's kind of backwards. So what we do now is we take this equation and we're going to plug in 0 for y. So this would be 6x plus 2 times 0 equals 20. This is just 0. 6x equals 20. X equals 20 over 6, which can be simplified. We get x equals 10 over 3. And then what do we do with that? Well, x-intercept is where the line crosses the x-axis, so it's actually coordinates. So it'd be 10 over 3 for the x-coordinate and then 0 for the y-coordinate. So 10 over 3, 0.
Does it have to say a mixed number?
It doesn't matter.
Okay.
I mean, it'd be easier to visualize it if it was a mixed number, so it'd be 3 and 1/3.
Yeah.
And then for y-intercept, same idea, we're just putting in 0 for x, so 6 times 0 plus 2y equals 20. 2y equals 20, so y equals 10, and then your coordinate would be 0, 10. Yes?
I have a question about the test. Is it going to be online or on paper?
It's going to be on a computer. And then for 21, same process, x-intercept and y-intercept. Y equals 0 and x equals 0. Not it. Who is it? Hello, Taylor. What's up? And then from here, we plug in 0 for y. We get negative 4x plus 9 times 0 equals 36. What's up? Was there homework? Oh, like making it up?
Yeah, it was like one of the makeup homeworks because I didn't.
You'll be fine. We're doing a practice test which has the questions from the homework. So after you do that, you'll actually be better off than getting the packet.
So I can still make that.
I'm in the middle of a lesson, Taylor.
Huh?
I'm in the middle of class. I'm teaching. I got 30. We'll deal with the 6th period. Thank you. Appreciate it. Okay. X equals -9. And then we have our coordinates, -9, 0. Whoa. It's blurry. Okay, and then for y-intercept, we're plugging in 0 for x, so -4 times 0 plus 9y equals 36. 9y equals 36, so y equals quattro. Okay. Next, actually, while we're on this page, we'll just do these up here. You got that down? Moving up here. Okay. We'll start with the piecewise. Yay, piecewise. Starting with this, we're working backwards and we're actually putting the equation of the lines and the inequalities there. So actually, I'm going to break it up just like we did before. So just working backwards. It looks like this line is that portion. So this would be from negative, so x is less than -2 and less than or equal to -2. And then for this part of the line, it looks like it's from -2 to 1. So x is greater than -2 and less than 1. Open dot, so I didn't put a line under. And then last but not least, this portion of the line is from 1 on. So x is greater than or equal to 1. So we got that portion done. And now we need equations for the lines. So this first line, the orange line, if I were to extend this, because I need a y-intercept, it crosses right at -1. And my slope is down 1 over 1. So our slope is -1. So -x minus 1, y-intercept of minus -1. Oh wait, it's not -x, it's positive x. I'm looking, so up 1 over 1 this way. -x would be like this way. Okay. For the next one, y-intercept is at 0. That's easy to see, which is nice. And now we just need to find the slope. It's going down 2 over 1, so our slope is -2. So just -2x plus 0, which we don't write. And then for the last one, it is at y 1, 2, 3, y equals 3. So 3. And for the step functions, like I said, I'm not sure if these will be on the test or not, but these ones are rather simple. So I might put a simple one on there. Well, I'll tell you for sure tomorrow. But this here has a step for the x and then plus 2, so that would be up 2 from the origin. So up here. And then from here, we just do those little segments like that with a closed dot and then open dot. And then just go up 1 each time because the slope right here is 1.
And you can also go over 25.
25. You're already over on 25?
Should be. No, I skipped like 22.
Oh, okay. And then 15, it's within the brackets plus 3, so that would be left 3. So from here, left 3, 1, 2, 3. And again, same thing. Close dot, then open dot, and just step up. And then the other side where we're graphing, this is where you guys were pretty strong, is with the graphing of the quadratics and absolute values. So moving on, ready? Okay, next, over here. Okay, so here we're graphing quadratics and absolute value. The first one is a quadratic. It doesn't have a place for you to write the transformation. You might just want to jot down what the transformation is. It is a quadratic. It's going to look like this. -1 would be right 1. And -5 would be down 5. And then the 2 is a stretch, which we'll get to in a second. Okay, so right 1, down 5. 1, 2, 3, 4, 5. And then from here, we need to find what points are actually going up. So you choose some x values that are close to this one. This one's at 1, so maybe 2 and 3. And then from there, you plug these into the equation to find the output. So 2 times 2 minus 1 squared minus 5. I get -3. 2 squared is 4 times 2 is 8. 8 minus 5 is +3.
Could you also do 0?
You could. Yep. Okay. Then plotting these points. 2, 1, 2, 3. And 3, 3. So here's my points going up this way, and then I'm also going to have those same points going up the other side. Like this. And then from here, domain -infinity to infinity. Range is 1, 2, 3, 4, 5. So my lowest y value will be -5, and then it goes up to infinity and beyond.
Don't you have to stretch it?
What do you mean? Well, the stretch was part of the equation, so it is stretch, yes.
But when it says reflect over x-axis and then you have to do like up 4, would it be down 4?
No, because the reflection's like, no.
The
You'll show-
reflection is just saying that instead of
Pointing
going
down.
like this, it's gonna go like this.
Yes.
How do you know what to put the points? Like when you
If it's a quadratic, for this shape, when it's a quadratic, then you have to do the points. Is that what you're asking?
like when you go up to onto the left one, like to go.
I'm not actually going up 2 into left 1. I'm using this 2, -3. So I went to 2, -3 to make that point.
Oh, okay.
But yeah, you might be recognizing that there is a correlation. I am going up 2 over 1, and then for the next one, it's getting squared somehow, plus the other I don't know. So it's going to get exponentially greater. But the specifics in it. Yes.
So is like the stretch how much you would go up and right, or would you have to use a table for quadratics?
So for the first point, you could technically go up
Yeah.
and over. But after that,
So it's best to use a table.
yeah. Then 23. This one's absolute value. It has that negative sign as a reflection, so it's going to be pointing down like this. +2 would be left 2, and then +3 would be up 3. So left 2, up 3, 1, 2, 3. It's just a -1, so I can go down 1 over 1 for this one. It makes it so much easier.
The slope is just -1. Right?
Yeah, so it makes it so you can just count. Domain, -infinity to infinity and beyond. Range, the lowest y value will be -infinity, and then the top one will be 1, 2, 3. Then 24 is a quadratic as well. We have a stretch of 2. X plus 3, that would be left 3. Stretch of 2. So 1, 2, 3. And then I'm going to go up 2 over 1.
What's a stretch?
Depends which one you're talking. It's like
No, I was just asking.
it's 2. It's like, that's complicated, Maverick.
No, you're good.
And then lowest y would be 0 and to infinity. Okay, next. You guys good? I still see people writing. Okay, 25 and 26. 25 is a quadratic. It has that negative symbol, so it's going to be a reflection. It's going to be pointing down. Left 1, up 4. 1, 2, 3, 4. And then I need coordinates to plot it. So from -1, I might choose -2, -3. And then using this equation, I'll find the y value. So this would be -1 squared is +1 with the negative. -1 plus 4 is 3. And then range, bottom value will be -infinity. The highest value will be 1, 2, 3, 4.
Is this all we're doing today?
And then we're going to go get our books.
Right.
Correct, yeah. 26, x squared minus 4. It's a quadratic, down 4 for the starting point. 1, 2, 3, 4. And then, as far as my points go, I'm going to choose 1 and 2. So 1 squared minus 4 would be 1 minus 4, -3. And 2 squared minus 4 would be 0. Domain -infinity to infinity. Range, bottom value 1, 2, 3, 4. So -4 to infinity on beyond. Then 27 and 28 is the inequalities where we shade the top or the bottom part. Here, y is greater than absolute value of x minus 2, so that's going to be down 2. So 1, 2. And it's just a slope of 1 like this. And over here.
So what's with like the y is greater than?
That's the part you shade.
Oh.
Y is greater than, so we shade all this.
And it's dotted, right?
Oh, good call. Yes, it is supposed to be dotted. I did that in my last class too. Yes, it's supposed to be dotted. And 28, yes,
So with the absolute value bars, it's always gonna look like that, like.
correct, yeah. .28. For this, in order to graph that line, I need to have it in y equals mx plus b format, otherwise I can't really see my y-intercept and my slope. So I'm going to rearrange this equation to get it into a format that I can graph. So first of all, subtract 9x from both sides. And then the next step is to divide everything by -3. But remember, when you divide by a negative number, it changes the sign in the opposite direction. So we get y is greater than or equal to 3x. -12 divided by -3 would be quattro. And then from here, we can graph it. 1, 2, 3, 4. And the slope would be up 3 over 1. And then graph the line.
Yeah.
Oh wait, did I? No, I did that.
No, it's not quadratic.
Okay. I didn't mess something up, right?
No, that's right.
Is it absolute?
Okay.
value?
No, it's
No,
not.
it's not.
There's no
No,
absolute
it's
value lines.
Thank you, Sharia.
That's right.
It's just a line.
I think I'm just paranoid because I make mistakes a lot. There's just so many things, little things to remember. Yeah, it's okay. And then from here, y is greater than or equal to, so we shade above. Yeah.